All right. Good morning. I hope everybody's doing well today. So I'm going to go ahead and run through the housekeeping items again. I'm going to try to make it as quick as possible, so just bear with me. First up, contracts. Okay. Does anybody still have a contract? Okay, a signed contract from you and your folks that you need to turn in. Anybody today? Okay, no, fantastic. Okay, so if you've already turned that in, thank you very much. It's going to be probably tomorrow that I'm going to go ahead and start looking through those, looking through College Board, seeing who still owes me something, and I'll go ahead and start talking to you hopefully later in the week. Let's run through the expectations very quickly. I know this is getting kind of old, but you folks are doing a great job. Be on time, grab the materials from the front bookshelf, be in your seat and ready to go. We're going to make sure those calculators are back up here before we leave. And again, still no electronics. Unfortunately, we got to have all that put away. Now, I already mentioned the College Board website. So if you've not already logged on and joined fourth period's AP pre-cal class, please try to take care of that as quickly as possible. Definitely by this weekend. If you're having any issues, remember I've got a step-by-step instructions on the website. I got the number here, or I'm not really technologically savvy, but come on in. I'll bet we can find our way to get it done. Okay, so that's the website for our class. So this, absolutely, if you've not already joined our Google website, please go ahead and take care of that today, especially if you were absent. It has everything you're going to need. It's got the video links, the digital copies of everything we talk about. And even if you're not absent, it has all of that information. In fact, if you go ahead and take a look, I did this morning go ahead and already post next week's material. So you can go ahead and take a look. What are we doing next week? When is homework due? When are we going to be taking a quiz? All that good stuff is already there. Okay. What's happening 7th period Friday? Fire drill. Okay, so we already talked about if we had a fire drill during this class, what we would do. Remember, we're going to go out the door, down the stairs, outside to the sidewalk, to the east side of the building over here. But super important, you got to find somebody. Why? Got to take attendance. I got to take attendance on Crisis Go. I want to make sure that everybody made it out. But that is 7th period, the end of 7th on Friday. So we're going to talk about the homework today. We'll start with that. Then we'll move on with the next lesson. But you have your first quiz tomorrow. How are we feeling? Good. Okay. Kagan, he's got this. Okay, all right, gotcha. Okay. How many people went home last night and did a few of those word problems from that resource I had? Oh, okay, some hands are going up. Fantastic. Okay, so they are available. All right, well, let's go ahead. Let's get started. Now, before we go ahead and move on to angles and their measures, we're going to talk about the assignments. So here we go. Now, I also want to, there's a few people I need to talk to before the end of class. And on a Wednesday, we get out of here at 12:04. So definitely by, let's say, 11:54, if I'm still, doing math and we're all focused, but if somebody notices, let me know so I can know to go ahead and stop. Okay. But questions on the assignment. And remember, the things about the assignment, when I say they're due on a certain day, that just means that's the day we're going to go ahead and discuss any difficulties you have in class. If you're not ready to turn it in, or some people have already asked me, can we just hang on to it as part of a study guide for the quiz tomorrow? That's fine. If you want to go ahead and turn it in tomorrow, Friday, never. Okay. I mean, the homework only serves two purposes. One, practice the skills, make sure you feel comfortable with the material. But number two, if you ever need to retake, that's when you'll want to have it done. So, yes, ma'am. 19. 18. Okay. So 19, it says find the acute angle theta that satisfies the given equation. We're only going to give this in degrees, though. Okay, so number 19, it says sine of theta equals √3/2. So the one thing you probably are wondering, how would we do this without a calculator? Well, if you actually started to work through a lot of these problems, you're going to realize every single one of these triangles is special. So it's going to end up being a 45-45-90 or a 30-60-90. So in number 19, we start with sine. I'm going to go ahead and just draw a right triangle here. Okay, I'm going to get blue. And you notice I've got different types of triangles. You can draw it however you'd like. But what is sine's ratio? It's what side length over what other side length, James? Opposite over the hypotenuse, yes. So if they're giving me this ratio, I already know the opposite length and I know the length of the hypotenuse. So it doesn't matter where I go ahead and place my angle theta as long as my appropriate information is correct. So for example, the side opposite theta would be the base, so that's square root of 3. The hypotenuse is 2. Now, I've already mentioned that it's going to be a special right triangle, but if you didn't recognize that beforehand, you've got two sides of a right triangle. How can we find the third? Pythagorean theorem. That's exactly right. So if I were to run through the Pythagorean theorem, you're going to find that height's 1. Did anybody want me to actually show that? Okay. So what type of triangle is this? This is a 30, 60, 90. Now, this angle theta, it has to be either 30 or 60. Which one? Okay, 30. We're close. 60. There we go. But why? Peyton? That's exactly right. Think about a characteristic that you learned in triangles back in geometry. The smallest angle has to be across from the shortest side. I mean, that's why hypotenuse, the longest side, is always across from the biggest angle, right? So in this case, square root of 3, and you can double check me in the calculator, but that's roughly a 1.7. Because it's the longer leg, that means that it has to be across from the larger angle. Yeah, so that's got to be 60 degrees. Ariana, is that good? Okay. What else? Number 4. Number 4. Okay, so it says find the values of sine, cosine, and tangent of theta. So we only have to find 3 of these. Okay. So let's see here. Number 4. Now, in order to go ahead and find these, we do need that missing leg. So right now, 8 is the adjacent side. 17 is the hypotenuse. So this other one is going to end up being the opposite. Okay. Well, can anybody tell me what that height is? This is actually a Pythagorean triple. It's 8, 15, 17. Now, a Pythagorean triple are just 3 values that satisfy the Pythagorean theorem, and there's an infinite number of them. But the more that you actually can recall, the easier it'll make your life in a lot of instances like this. I mean, if anybody wants me to again, I can run through Pythagorean theorem. You want me to do it on this one? Okay. So let's say we didn't know that was 15. This time, let's go ahead and say maybe that's B, this is A, and then there's our C. Okay, so A squared plus B squared equals C squared. So 8 squared plus B squared is equal to C squared. Okay. So I'm looking for an 8 squared. We know that's 64 plus B squared. And a 17 squared. Oh, no, that's 13 squared. 200. Oh, no. 289. Okay. 289. And now we'll go ahead and subtract those. So B squared is equal to 225. And then when I take the square root, what do I get? Boom. Okay. So we still have it. Okay. And now that I've got the entire figure, this is when we just find the ratios. So we want sine of theta. So for example, that would be the opposite over the hypotenuse. So that's 15 seventeenths. If I want cosine of theta, okay, well, that's going to be the adjacent over the hypotenuse. So that would be in 8 seventeenths. And if I want tangent of theta, remember, we're not talking about the guy who spent too much time at the beach. Tangent. It was funny. Thank you. I appreciate it. Yeah. Okay. I like it when people don't laugh, but they acknowledge that it was funny. There you go. James just like, let's get back to it. Okay. So that would be uh, 15 over 8. Yeah. Opposite over adjacent. That little bubble there for me a second. Okay. And Rami, is that good? Okay. Anything else? Yes. 21. 21. I believe. Okay, let's take a look at 21. All right, so let's say I go ahead and use the same figure here, but I'm going to put theta in the base angle this time. Okay, bless you. So we just saw that cosine has a ratio of the adjacent length over the hypotenuse. So I know that the hypotenuse length is 2, the adjacent length is root 2. Well, if I were to use the Pythagorean theorem, what would the height be? Not 4. Well, let's see. Let's go ahead and call this a this time. So a squared plus b squared, so the square root of 2 squared, is equal to c squared. Okay. So a squared plus, what happens when you square a square root? Yeah, they just cancel each other. They're inverses. So that's simply 2 is equal to 4, 2 squared. So a squared equals 4 minus 2 will give me 2. So the square root of 2. Okay. Well, what do you immediately notice? The legs are identical, so what special triangle is this? It's a 45, 45, 90. So that angle right here, that's 45 degrees. Ma'am, does that make sense? Okay. All right. Now, there is one thing I wanted to go ahead and show you. A lot of people have been asking about this today. So you remember I did show you how on the calculator to change the mode from degrees and radians. Even though we don't know what a radian is, we still know they exist, right? Okay, so take a look at the top of the back side of the page. Numbers 9 through 14. Remember I said 10 and 11, we're going to omit those. Okay, but let's start with number 9. I just want to show you. That's the sine of 78 what? What's that? Oh, Carolina actually asked if you're going to go. Okay. And I don't think I showed you, we have our lanyard. Yay. Huzzah. Okay. So that sine of 78 what? How do you know that's degrees? It says it, right? There's that little circle, that little notation, okay? Now, while that's 78 degrees, look at number 12. Tangent of pi over 8. What would you think pi over 8 is? Is it degrees or is that a radian? Why is it a radian? Not only do you have pi, but there's no little circle. Unless it tells you specifically it's a degree, we have to believe it's going to be a radian measure. Okay, so same thing with number 13. That 2.85, degree or radian? That would be a radian. So you want to make sure your calculator is in the correct mode when you input it. Yes. Okay. Let's see here. So let's do it this way. What's your 1,000 number? 001. Okay, a little bit slower. 913. Okay. So there we go. So we'll continue. So you're going to the restroom. And there you go. Now you good? Okay. That's fine. Sorry, you went a little fast on those numbers for me. Okay. All right. So we're good. Okay. If you are ready to turn in the homework, you can go ahead and pass it up. Now remember, I am looking for completion. So if you've got parts of it that aren't completed, I won't be able to do anything with it. I'm just going to have to give it back to you. Okay. But if you have it completed, you're ready to turn it in. If you want to hang on to it as a study guide, completely up to you. Well, I forgot to change them on the key. Because I decided not to do the radians this early, but they should be just degrees. Oh, yeah, so yeah. All right, thank you. Thank you. Thank you. Thank you. Thank you. Okay. And then remember, fourth period is going to be on the bottom left over here, just right next to Flash. Okay. All right. Well, before we go ahead and take a look at our new lesson, what I'd like you to do is go ahead and pull out a sheet of paper. Now, if you don't have a sheet of paper readily available, I've got a whole stack of blank paper right here. If you'd like one, just raise your hand high, so I'll know. Okay, so there's 2 in this row, 3. Okay, you need a sheet of paper. Yep. So 1, 2, 3, 4. Give me a notebook. I mean, whatever you like, as long as you have a sheet of paper. There you go. Okay, 1, 2, 3, 4. So Alex, you don't need one? Okay. There we go. So 3 in this row. And we got 1, 2, 3, 4 in this row. Okay. All right. So we're going to go ahead and do this from time to time, probably at least twice a week, because when we get to the unit circle, we definitely want to evaluate trig functions, and we want to continue to practice and make sure that is something that we have down pat, that we can do, in our sleep. So what I'm going to do, I'm going to give you 2 minutes once I go ahead and show you this, right? So you do not have to copy the instructions. Okay, here we go. Okay, so theta is going to be an acute angle such that tangent of theta is equal to 1/3. So given that, I want you to diagram the lengths on this right triangle and then find me the 5 remaining ratios. Okay. So 2 minutes. Where's my timer? Begin. Okay, so the ratio you're given is 1/3 for tangent. Okay, especially going into tomorrow's quiz, you absolutely need to know the ratio for each of the 6 trig functions. Okay, it would also probably be helpful to know which ones are reciprocals. Seconds. Thank you. All right, that is 2 minutes. Here is what we should be getting. Okay. Now your triangle might look a little different if you place theta maybe above as opposed to what I did, but you should have legs of 1 and 3. The square root of 1 squared plus 3 squared is the square root of 10. Then once you have that, you go ahead and find those ratios. Okay. Remember, always simplify if you can. Rationalize if necessary. That means remove the radical from the denominator. Okay. How many people got all of these? Okay, that's good. That's a good number going up. Okay. If you're still having some trouble with this, come on in. Let me help you. Okay. Got tutorials. So, like I said, we're going to do things like this occasionally. Probably, if not next week, probably the week after, definitely, once we talk about the unit circle. We'll probably do it a couple times a week. Could be for a grade. Sometimes it's not going to be for a grade. Like this one wasn't for a grade. It was just the first one we're going to do. Okay. But if you have questions, let me know. All right, so go ahead and put that to the side. What's up? Okay. So let's go ahead and see. Let's go ahead and run through this. So, Kagan, what is tangents ratio? It's what length over what length? Anybody want to help me out? It's the opposite length over the adjacent length. Okay, so if I place theta right here, then the side opposite that, that's the 1. The adjacent, that's the one right here below. And of course, the hypotenuse is across from the 90 degrees. So let's say this is AB, and we didn't know what C was. So A squared plus B squared equals C squared. So 1 squared plus 3 squared is equal to C squared. So 1 plus 9 is equal to C squared. So 10 is equal to C squared. But again, I don't want C squared. I want C, that distance. So that's why I had to take the square root. So that's why I know that length there is root 10. Now, once you've got all 3 of these values, then all you're doing is substituting in. Like, for example, sine is always the opposite over the hypotenuse. Okay. Well, I'm looking here. My opposite length is 1. The hypotenuse length is root 10. Okay. And there you go. But that doesn't look like what's on my paper, though. Okay. So what we say is we rationalize that. So in this case here, I would have to multiply by a version of 1, because square root of 10 over square root of 10, that's 1. If I multiply straight across, 1 times the square root of 10. Now, square root of 10 times square root of 10 is the square root of 100. And see, that's why we multiply the square root by itself, because perfect square, we can simplify. So that's where I get the square root of 10. Okay, but does that make more sense? Oh, because whatever ratio you're provided, they represent 2 lengths of the triangle. Because remember, that's exactly what a trig function does. For whatever angle you plug in, it takes the ratio, or it divides 2 specific side lengths of the triangle that has that angle. Theta. Yes, exactly right. That's how you start filling in your triangle. That's exactly right. Okay, good, good, good. Are there any other questions on that? If I can get this to erase, that would be fantastic. There we go. All right. Now remember, that quiz tomorrow is right triangle trigonometry. We're starting a brand new lesson, angles and measures. This is not on the quiz tomorrow. Okay. There will be a quiz over this next week, but not tomorrow. Let's see what we got. Engineers in the ancient world discovered ratios within right triangles as they learned fundamental engineering skills. The secrets and patterns necessary to understanding circles and spheres helped in the development of trigonometry, which we get to enjoy today. Yay. Our chapter begins the journey into trig with an introduction into angles and their measures. So this lesson is very vocabulary heavy. Remember, these first lessons are setting the foundation for what we're going to do as we move forward. Okay, so angle characteristics. An angle is determined by rotating a ray about its end point. Okay, so a ray, you might remember from geometry, is going to be a line that goes forever but in only one direction. Okay, so the vertex is the end point of the ray. The initial side is the starting position. This is where you start rotating. So wherever you start rotating, we refer to that as the initial side. You can rotate either in 2 directions. You can rotate counterclockwise, okay, or you can rotate clockwise. Now the terminal side is the position after rotation. Wherever you stop, that's your terminal. The angle is created between the 2. Okay, so standard position. So angles that are in standard position. Okay, so I highlighted that because it's an incredibly important term. We're going to start looking at these coordinate planes here, the intersections of the x and the y axes, and if we start rotating from the positive x-axis, if that's our initial side, that's what we call standard position. Okay. Now, a positive angle is going to be determined by a counterclockwise rotation. So if I start here and I begin to rotate like this, That's counterclockwise. That results in a positive angle. Okay. Negative angles are determined by a clockwise rotation. So if I start in standard position and I rotate like a clock moves, hence clockwise, that's a negative rotation. Okay. So people are kind of confused about this in the beginning. We're not saying that the angle itself is negative. Okay. The negative simply tells you what direction you're going to rotate. Okay. Now let's talk about coterminal angles. These are two angles that are in standard position. Okay, now remember, vocabulary. Standard position means I start rotating from the positive x-axis, okay, that have the same terminal side. The terminal side is where you stop rotating. These are what we call coterminal angles. Now, we can find an angle that's coterminal to a given angle by adding or subtracting one revolution. Okay, so let's go ahead and fill in our first coordinate here. Now, before I rotate, we're at 0 degrees. Okay. Remember, we start rotating on the positive x-axis. That's my standard position. What's one full revolution? 360. Okay. So let's go ahead and break it up and see what the other axes are going to look like. What's half of 360? 180. Okay. Now we know half of 180, or the measure of each quadrant, is what? 90. So now, what would 3/4, 3/90s be? 270. Okay, here we go. So now, knowing this, any given angle is going to have many coterminant angles. So here's the thing, that's kind of an understatement. There's going to be an infinite number of coterminal angles. And you're going to see why in just a second. Here's an example they give you before we even get one we'll do together. It says beta equals 36 degrees is coterminal with all of the following. Well, let's see why. First off, would everybody agree that 36 degrees would be in quadrant 1? Okay. So if I start here at 0, it's a positive angle, so I'm going to rotate counterclockwise. So let's say from here to here, that's 36 degrees. Remember, it's just a rough sketch. Okay. So let's say that's 36 degrees. What it really comes down to, when we're talking about coterminal angles, you're looking for two angles that have different measures, but the exact same terminal side. You're simply adding and subtracting multiples of 360. So let's say I go ahead and start here. I rotate to 36, but let's say I'm going to go a full rotation beyond that. What's 36 plus 360? 396. So 396 degrees could also be represented by the same sketch. They have the same terminal side. Now, I could go ahead and rotate an additional one. So all the way around again. But this time, what's 396 plus another 360? 756. Okay. All of these are what we call coterminal. Okay. They're different angle measures, but they have the same terminal side. Now, why do we have an infinite number? I could sit here and rotate forever. I could always add 360 and it'll never stop. Okay. Now, you can also do this in the other direction. Let me go ahead, stay here. So instead of rotating counterclockwise, let's rotate clockwise. So I'm going to start here in standard position. Let's say I rotate over here. But if you're rotating clockwise, you're subtracting. What's 36 minus 360? Negative 324. So negative 324. And let's say I want to go one full revolution past that. So what's a negative 324 minus 360? There you go. So that's why all of these angles are coterminal. They have the exact same terminal side. Is everybody starting to get the idea? Okay. Like I said, put very simply, all you have to do is just continually add or subtract 360. That's why we have this expression here. Theta plus 360 in, we're in. So this curvy E in mathematics, that means belongs to, or is an element of. So we're saying it's an integer. Okay. You remember the hierarchy of the classification, like real, rational, all that good stuff? Does anybody want me to define an integer group? Okay, let me do that. So the integers are made up of a couple of different values. First, the very first values you ever learned when you were younger. So just your counting numbers, 1, 2, 3, dot, dot, dot. Okay? And then as you got older, you started to be exposed to more ideas. So you were taught about the idea of nothing, so 0. And then finally, you were taught about operations like subtraction. So you have their opposites, -1, -2, dot, dot, dot. Okay? That's what the integer set looks like. Now, remember I said we're adding or subtracting 360? Well, what are some of my values going to be? Negative, so that's why we don't need to have plus or minus 360, because we already have negative values of n. That takes care of the subtraction. Okay, so let's try an example. The one they give me is 220. So let me get this out of the way. Okay. All right here. Okay. All right, so we got 220 degrees. Now, typically, I'm only going to have you find one positive, a counterclockwise, and one negative, a clockwise. Okay, so what quadrant is 220 in? The third. So I'm going to start here. Let's rotate around. Let's say this is my angle 220 degrees. I guess I'm going to jail. Okay. What are you in for? My phone rang. Ooh. Okay. Anyways. All right. So it really comes down to this. All you have to do is just add or subtract 360. So let's find the positive one first. I'll do this one in green. So if I start here, if I rotate around to 220, I'm going to go one additional revolution. So what's 220 plus 360? 580. So 580 degrees, that's a coterminal angle. It would also be represented by that same sketch, the same terminal side. Now let's find a negative, a clockwise. So if I'm going to start here, I'm going to rotate clockwise until I hit it. But what's 220 minus 360? Negative 140. So all three of these, they're what we call coterminal. Okay, is that making sense? Does anybody have any questions on that? Okay, not too bad, right? No. Oh, yeah. You got time? Yeah, we got plenty of time. Okay. Cool. And there's one last thing I want to go ahead and introduce before you take off today. It's what we call a reference angle. Okay. So what's a reference angle? So given an angle in standard position, that means we start rotating from the what? The x-axis, the positive x-axis, okay? Its reference angle is the acute angle formed by the terminal side, remember that's where we stop rotating, of the given angle and the closest x-axis. I might even go ahead and write the word closest in there, okay? So you'll see what I mean in just a second. Let's just get right to an example. The angle at left is 210 degrees. So let's say, rotating around here, that measures 210. Everybody's okay? Okay. Now, by definition, a reference angle is created using the terminal side where it stops rotating and the closer x-axis. So which one's closer? Is it the negative or the positive? It's the negative. So this right here, that's the angle I'm looking for. Well, we know this is 210 degrees. That closer x-axis, that's 180. So all you have to do is subtract the angles. What's 210 minus 180? 30. So that reference angle is 30 degrees. The thing about a reference angle, always positive. It will never be, there's never a circumstance where it's going to be negative. Okay? It's always positive. Okay, well, let's take a look at a couple of these. So we start at 0 degrees. We have 90, 180, 270, all the way around to 360. Okay. What quadrant is 150 in? Okay, so I'm going to go ahead and say absolutely right. Perfect. So let's go ahead and say that right there is my 150 degree angle. Okay. So the reference angle, it's created using the terminal side where I stopped and the closest x-axis. So again, it's the negative. So this time 180 is the larger of the two. What's 180 minus 150? So this reference angle is also 30 degrees. Okay, that's all there is to it. There's no tricks. Okay, let's try 2B, or not 2B, am I right? I mean, this isn't English, but it's going to be literature. They're all good. But I appreciate you saying that. Yeah. Okay. Yeah. Okay. So I'm not going to put the degrees on here now. Where is 315 degrees? What quadrant? Fourth. So let's say I start here, rotate all the way around. So let's say this is 315 degrees. Okay. Now this is the first one we've seen where the closest x-axis is the positive. Now, it's not 0 any longer. We've almost completed one full revolution. So that x-axis represents 360. Okay, so what's 360 minus 315? So that would be a 45-degree reference angle. Okay. Yes, sir. Say one more time. Oh, that's a good question. You're absolutely right. It bisects that quadrant. It just took me a second to realize what you were asking. But the thing is, we don't equate this to the y-axis. It's only the x-axis with a reference angle. Okay. Now, what's different about 2C? It's a negative. So here's the thing. We're still going to start at 0 degrees, but negative means we're going to rotate clockwise. So one full revolution is a negative 360. Half of that is a negative 180. But remember, because I'm rotating in this direction, negative 90 degrees would be right there. Then up here, we would have a negative 270. Remember, it's not that the negative represents the actual angle. It's just the direction that you're going to rotate. That's all that is. Okay. So in this case, where would negative 120 fall? In the third quadrant. Yeah. So it's bigger than negative 90, but it's smaller than. Oh, okay. Reverse that. I'm going to go ahead and stop talking. Here's a negative 120. Okay. Let me just ask this question. It's once again. Here's my terminal side. We stopped in the third quadrant. Here's my closest x-axis. It's the negative again. Okay. So of the two, negative 180, negative 120, which one is bigger? The negative 120. Because it's closer to 0. With negatives, the larger the number looks, the smaller it actually is. Okay. So I'm going to take negative 120, and I'm going to subtract that negative 180. What happens when you subtract a negative? There you go. There you go. Now, let's say that you accidentally, switched those and you subtracted them and got negative 60. I mean, you're still okay. You just got to realize the reference angle is always what? Always positive. Always positive. Okay, Carolina, you had your hand up? Oh, okay. Now, I want to go ahead. Okay, so it's about time for me to go ahead and stop. I want to show you this last one before we do. Now, this one's not on your notes, but let's say I gave you 35 degrees. Okay, so I'm going to go ahead and draw 35 degrees right here. What's its reference angle? 35 degrees. Okay, because by definition, it's created using the terminal side and the closest x-axis. So an angle in quadrant 1 is its own reference angle. Is everybody okay with that? Fantastic. Okay, we are done for the day.